Thanks. Welcome, guys. So this video, let's talk about least radicals from Ramanujan. So this video, I only solved the second one because this is famous and everybody already do it. So I still want to do it and make a video. And the next video, we will solve the general least radical like this ax plus n plus a squared plus x. Yeah, man, this is general one. Okay, so. Yeah, so hope you guys subscribe to my channel so that you will not click the notification button so that you will not miss my latest video. So let's solve the first one. Yeah, so this one is a very famous that Ramanujan posted some mathematical society ask about this, right? So some famous least radical like we already proved in the previous video or many other already proved is that this guy will give you 2, right? But how about this guy? Okay. So let's see how Ramanujan get an answer. This is very difficult, right? So let's talk about results. So the answer is 3, okay? And in order to do this, let's maybe see the method one. Okay, so maybe maybe we only talk about the results and do not talk about the. Okay, so let's talk about the results. So the method is that you can write 3 as a square root of 2 times 4, right? Because this is 9, and then you just write 1 plus and you can write 4, right? You can write 4 as a square root of 1 plus 15, right? So you can write the square root of 1 plus 3 times 5. So you see you already got 2, get 3, get 2, get 3, and then next that you just write 5 as 1 plus 24. So you get the square root of 1 plus 4 times 6, right? So you get 1 plus 2. 1 plus 3, 1 plus 4. Okay, and the next is that you just write 6 as 1 plus 35, so it's 5 times 7. Okay, so it's amazing that if you keep going, then the sequence you get is 2, 3, 4, 5. And I will leave an exercise to you to show that. Okay, so maybe that's proved by for you. Okay, so now you already see the pattern, right? If you already see a pattern that if you keep doing, you get 2, 3, 4, 5, and then next you just write 7 as 1 plus 48, so it's 6 plus 8. Okay, so 6, and then you keep going. Okay, so in order to prove this is actually linear, then we need to show that let's see. Suppose I got something called n. Okay, I got something called n here. Let's say I got something called n here. Then this is 6, right? This is 6. So this is 1 plus 5 times 7, right? So the structure we get must be n times 1 plus n minus 1 n plus 1. N minus 1. Let's see. So if this is n, this square root will be n plus 2. Okay, so the key is that one can always write n plus 2 square as a 1 plus n. So this is let's say n squared plus 2 and plus 4. Okay, right. So 4 plus 4. So you get 1 plus n squared plus 4 n plus 3. So you get n plus 1 n plus 3. Okay, so this tells you that anytime if you see n times n plus 2, you can always write as n times 1 plus square root of n plus 1, n plus 3, right? Because this is just right, just this one, and then you keep going, right? You can keep going. So anytime if this is n and n plus 2, then the next one must be n plus 1. So you always get from n to n plus 1. Okay, so from this observation, we know that it must be linear. Okay, so this rigorous proof that these results will be famous Ramanujan number called famous results. Not Ramanujan number, famous is 3. Okay, in the next video, we will prove the general powerful results f of x, which is a more difficult form, and we will solve this least integral. Okay, see you guys next videos.